All right, problem number 12. We want to evaluate the limit using L'Hopital's rule when it's convenient. All right, so this given problem, we are taking the limit as x goes to infinity of the square root of x minus 8 minus the square root of x minus 7. Now, if we were to plug in infinity, this would get bigger and bigger, and this expression would basically be infinity minus infinity. So this is an indeterminate form. We can't solve this, so we would have to try to get it into L'Hopital's rule, which would be 0 over 0 or infinity over infinity. So when it's in that form, we can do L'Hopital's rule. Example 5 in the textbook factors out an x squared and then rewrites it, and we can get it into L'Hopital's rule, but the example shows a easier method. It's kind of multiplying by the complex conjugate, or using that difference of squares. If you remember difference of squares, you have a squared minus b squared, and that's going to, when we get those squared, it allows us to get rid of those square roots, is equal to a plus b, a minus b, a plus b times a minus b. Now that's kind of running off, but that's the difference of squares formula, a plus b, a minus b. This is a and this is b, so I have a minus b. I need an a plus b. So I can't just multiply that. I want to do it on top and bottom, so I keep it even. It's kind of like multiplying by 1. So we're going to multiply this expression by square root of x minus 8 plus square root of x minus 7 over square root x minus 8 plus square root x minus 7. So this is just a trick in math where you multiply top and bottom. It's like disguising a 1, but putting it in terms that we can need it. What's going to happen on the top? A minus b, a plus b. Only difference is the sign in the middle. We'll get both of these squared on the top. Limit x goes to infinity. And then we'll have x minus 8. When you square the square root, it gets rid of it. So we'll have a x minus 8 minus in the middle. And then we'll have x minus 7, because that's going to get squared as well. And then it'll be all over the bottom, which is square root x minus 8 plus square root x minus 7. Simplifying, distribute, so this will be a negative x and a plus 7. So negative, and that'll be positive. The positive x and negative x will cancel out to 0. Negative 8 and positive 7 will give us a negative 1 over All right, so at this point we have it rewritten. We can try to apply the limit again. So as x goes toward infinity, the overall whole bottom is getting really, really big. So this overall fraction is going toward 0. So again, remember, if I have a small number on top staying fixed, and the bottom is getting larger and larger and larger, say 1 over 10, 1 over 100, 1 over 1,000, this number is tending toward 1. That'd be negative 0.1, negative 0.01, negative 0.001. And so we're just trying to figure out what this overall value is approaching, and we can get it by just doing a manipulation of the problem. So the limit is 0 for this one. Didn't have to use L'Hopital's rule. All Alright, 13, we want to use graphing guidelines to make a complete graph, so a review section 4. So this is a cubic function. We can do some algebra and graph this. X cubed minus 2x squared plus x. So odd degree, and it's positive, so my right side is going up, my left side is going down. If I were to factor this, I can factor out an x, and this will be x squared minus 2x plus 1. We can see 1 times 1 is 1, and you add those, you get 2. Okay, so this will factor, we'll have x, and then x, 1 and 1. It needs to be a negative 2, so both minus. So we'll get 2 zeros. We'll set this equal to 0. So we'll get x equals 0, and we'll get x equals 1. That will be my 2 zeros. So this guy should cross the graph at 0, and it should come down and touch at x equals 1 because it's a double root. So C and B look close. If I zoom in a little bit better, looks like C, because it looks like it touches, but this one looks like it's maybe going across. This is the one that will show me the full screen. So we determined we should have a 0 at 0, which this one doesn't show, and then we should have 1 at 1, but it should only touch at 1. So that one doesn't look exact. Let's look at this one. It crosses at 0 and touches at 1, according to the zeros we found. So C is going to be our correct graph.